Okay, so I was saying the cutting, right? So we cut it closer to the right side. Okay, so this area has a little thickness. Right, just like the cross section that we show on the top. So this thickness is also in the parallel to the x-axis. So it also has thickness of dx. Okay, when you are cutting vertically, when you put your knife down, right, vertically, then the thickness is the dx. Okay, and then the area here is the a of x. Okay, so the volume of the sphere will be a of x multiplied by dx. And then here it says, please find the volume of a sphere with radius r. Okay, so this radius r is a constant. Okay, so for example, like radius of 5 cm, right? And then you would put the 5 centimeter into the formula, right? So we have to treat the radius as the constant. Okay, so we'll put that on the picture. So here will be r, up here is r, right? Here is also, it will be negative r, the coordinate, right? And down here is negative r. Okay, r is a number, okay, like 5 centimeter. And then where the area, the red disk, okay, the cross section is crossing the x-axis, it will be somewhere here, right? You see I drew a center there. So
Wait,
for,
so that's that's the center of the red part, right?
yeah, that's the center of the red, is where the cutting cuts through the x-axis. Okay, so for different location of the cutting, right? Different location of the circle, then you get different area. Okay, the closer to the right. Okay, let's say if I draw another one, right? Then the center will be here, right? So you can see the area of the green one is smaller, right? And also has a thickness. Okay, understand what I'm drawing now?
Wait,
Okay,
Jason,
yeah.
is the dx always the same?
Dx is just saying that it's a very tiny thickness.
Oh,
So
okay.
yeah, so it doesn't have a number. It's just represent it's a little thickness.
Okay.
Yeah, like the thickness of a slice of paper, right? So very tiny.
Oh, okay, I understand.
Yeah,
Yeah.
so it could be 0.00001. Okay, just something
Okay.
very tiny.
Okay. Thank
So
you.
yeah, so when you multiply a with dx, it just represents the volume of every single cross section. All right.
Okay.
So because it depends on the x, so I will put the x is where the red is touching the x-axis. Okay. And then it also, the red one also has a radius of its own, right? Radius will be here. Okay, so if I want to find, the goal here is try to find the area, right? The A is the area of the red part. So if I know the X, okay, let's back up a bit. Okay, how do we find area of a circle? What's the formula for area of circle?
Pi r squared.
Pi r squared, right? So area of that red circle, the R will be the blue line that I just drew, right? I'll use the capital R. Okay, so if I know the x, how can we find the radius of the red circle, right? Because I want to find the area of the red circle so I can get the volume, right? So my question is, if I know the value of x, how do we find the length of the radius for the red circle? Okay, I'll give you a few moments, think about this.
Wait, Jason, I have a question about the radius part.
Yeah,
For like the cross section drawing that you did above, like the volume of one cross section equals to area times dx.
yep.
How does that work for circles? Is it still like, is it just like pi r squared times dx?
Yes,
Oh,
yeah, because it's
okay.
circle, right? So circle will be pi r squared times dx. So for example here, right? If we do the next step, it will be pi capital R, right? Because capital R represent the radius of the circle, right? Square dx. Okay, so this part represent the volume of cross section. Okay, CS. Okay, and we want to add up all the volume of cross section all the way from negative R, right, from the left side to the right side. Okay, so that's the boundary, right? So if we are able to add up all the round disk, then we can get the volume of the whole sphere. Okay,
Wait, sir?
so yeah,
Sorry.
yeah.
Go ahead. I don't really understand the negative r to. Oh, okay, I see it now. Sorry,
Then
I didn't really see the picture before until I just saw that. Sorry.
the negative R is talking about the left side, right? And then the right side, right?
Yeah.
We have infinite number of cross section. Right now, I only drew 3 of them, right? One right in the center, and then the red one and the green one, right? But in fact, there are infinite number of them.
Oh,
Okay,
okay.
yeah. And then we want to add them all up. That's what the integral is. Okay,
Okay, yeah.
so the question was, right, if I know the value of x, so let's say if x is 3, okay? For example, maybe with number it will be easier for you to think. If x equal to 3, and then the radius of the sphere is, let's say it looks like it's 5, okay? How can we find the radius of the red circle using these two information? I know the radius of the sphere is 5.
Wait, sir.
Yeah.
Wait, ax equals to pi r squared, right?
Yeah.
Okay, sorry. I thought I knew where I was going with that, and then I realized I didn't.
Okay, just think about when right now, okay? We know the radius of the sphere is 5 centimeter, for example, right? And then you know you are cutting the red part at x equal to 3. X equal to 3 is the same as saying from the center origin, right, to the center of the red circle is 3, right? So how can I use those two information so far, right, to find the radius of the red disk? Okay, let me erase the green one, right? So the picture doesn't look that confusing. Okay, you guys can keep thinking about this. Okay, I'm giving you more time because I know you can figure it out, okay? I'll erase the blue dot, okay? So you can, it's
Mr.
not that.
Jason?
Yeah.
I have a question.
Yes. What's the question?
Is the X the R?
The X is the location where the red circle is cutting through the x-axis. So it's not the
Oh,
radius.
so if X, oh,
So
okay.
when x equal to 3, you get the red circle, right? When x may be equal to 4, you get another circle, right? But the bigger
Oh,
the x, the smaller the circle because you are more closer to the end of the sphere, right?
yeah.
Okay, so
Okay.
x is just the location of the each cross section. So that's why the area is function of x, right? That's why I wrote down a of x. Area changes depending on location where you cut it. Anyone? How do you find the capital R? Okay, let's put it that way. With all the numbers that you have so far. Do you want a hint?
Yes, please.
Okay,
Maybe,
Lex, yeah. What do you
maybe
want?
Pythagoras, because then we know that x is 3, and then you can do I guess a triangle with
Okay.
the radius.
Can you draw on the screen for us?
Sure.
Okay.
This is the radius, right? So that's 5, and this is 3. So
Mhm.
we'll just use Pythagoras to find out what r is.
Okay. Did everybody catch that even though this is a bit broken?
Yeah.
Yeah? Yeah, did you all get it? What she's talking about? Can you raise your hand?
I think it's the drawing, but for whatever reason, I didn't think that that was the same length. But yeah, it makes sense. It makes sense now.
Okay, because the small r, right, the 5 is the radius of the sphere, right? So you can put the radius anywhere you want, right? It's always gonna be 5, right? It's around like a basketball, right? So it's same radius all everywhere. Okay, very good. I knew someone would get this one. Okay, so let's draw that there then. Okay, so let's put the I will use the green. Okay, Lex, can you help me erase the black line? Thank you. Okay, so this one will be 5, right? So of course we can use the 5 and then find the radius of the circle. Now let's do the same thing with the x, right? Because this one, the 3 is just there for you to help you think. Okay, otherwise too many variable. Okay, so I'm going to erase the 3 now. So just say it's a x. Okay, so x is any number, right? So the capital R will be, how do we find the capital R now, Jeffy?
5 squared minus 3 squared equals big R squared.
Okay, so to find the R, you need to,
Root 5 squared minus 3 squared.
very good, okay? So that would be, well, actually it's not 3 squared, we should put x squared, right? Because instead of 3, we have any x, okay? Just in general. So that will equal to 25 minus x squared. Now to make it more general, I'm going to take away the 5, okay? 5 is also there to help you think, right? So let's say if the radius of the sphere is just r, okay? So I'm going to make that r as well. So your capital R will now become r squared, small r squared minus x squared. Okay, remember r, the lowercase r is the radius of the sphere. Any questions so far? Okay, we got through the hardest part, okay? So back to the formula on the side. So now all we need to do is just to plug it in, okay? So we want to add up all the cross section from negative R to R of the volume of the cross section, which is pi R, which is R squared minus X squared dx. Any questions so far? Okay, and then the square, yeah,
Sorry,
Yes.
this might be a stupid question,
yes.
but isn't the root of R squared minus X squared squared R squared minus X squared?
Yeah, so it will cancel
Oh,
out. Very good.
okay.
Okay, that's my next step. Very good. Okay, so go up. Okay, we'll simplify that. Okay, it will be pi R squared minus X squared dx, right? Square root and square canceled out. And then because the sphere is symmetrical, right? So instead of adding all the disk from negative R to R, I could also just do from 0 to R, and then what?
Times 2?
Yeah, times 2. Kind of like the way we do area, right? When we see something symmetrical, we could just find one side and make the volume double, right? Because volume, it won't change, right? Volume is always positive. Okay, so that's all we need to do now, right? The setup is there. Now we can find the answer. Okay?
Wait, sir?
Yeah,
Isn't pi like pi is a number, right?
that's right.
So don't we also pull that out because it's
That's
constant?
right. You can just read my
Oh,
head.
sorry.
Right? Very good. Read my mind.
Sorry.
So pi goes out. Okay, then you get this. Yeah. Okay, so I'll let you complete the rest because I believe you know how to integrate this. Find the antiderivative and then sub in the A and B, okay? And keep in mind, the small r is a number, okay? A constant, okay? So R squared is also a number, right? So the only variable here is X. So please go ahead, tell me the final answer, okay? What it looks like. So raise your hand if you are able to reach the final look.
Hey, Jason, I'm confused where the 2 came from.
The 2 because I changed the boundary from instead of negative R to R, I change it to 0 to R. And 0 to R is half of the sphere, right?
Oh, okay.
So I find the volume of only half the sphere and then double it. So it will be the same as finding negative R to R. Make sense?
Yep.
Yeah, okay.
Sir?
Yes, Jesse?
Will there be a lawn?
No, there is no lawn.
Oh.
Yeah.
Okay.
Well, I could tell you the answer. It's in the red circle, right? Because that's the formula we're trying to get. Okay, so if you are able to find the formula for sphere, okay, you can raise your hand. Or if you get stuck, okay, also raise your hand. Then we can go over it. Okay, let's check the antiderivative, okay? See if you guys got the correct antiderivative. Okay, so Joan, can you tell us what's the antiderivative?
I'm not too sure because I kind of forgot what to do with the r since it's not really a variable, right? It's like,
It's a number. So if you don't like r squared, pretend it's 7.
yeah. So it'd
Yeah.
be r squared x
Yes, very good.
plus x cubed over 3.
Yes. Okay. Right. So that's the antiderivative. And then you want to go from 0 to r. Okay. And then sub in the values and subtract. Okay. Raise your hand if you can get 4 over 3 pi r cubed. Only Jesse found it. You just sub in, that's all. All right, please raise your hand if you get 4 over 3 pi r cubed. Okay, so 2 pi, r goes into x, so that will give you r cubed minus r cubed over 3, right? And then minus, now you need to sub in 0, but then 0 will make everything 0 on the inside, so minus 0, right? So minus 0 doesn't matter. And then you just combine like terms, okay? You should end up with this one. Okay, raise your hand if you have finished. Emily, any questions?
No, I just forgot to change the limits, so I just have to redo what I did.
Oh, the limits? You
No,
mean?
no, to because we said we'd do half, right? I
Oh,
forgot to change the negative r to 0.
I see, yeah.
So
Okay,
yeah,
okay.
that's it.
Yeah, so having the 0 is easier when you sub in, right? But you will still get the same answer if you do negative r to r. Okay, just a little bit more work. Okay, so finally, right, after all these years, you finally found out how they got this formula, right, for the sphere, okay? 4 over 3 pi r cubed using calculus. Okay, so this is called cross-section, right? We add up a lot of cross-section together to create a solid, okay? So we use this to show you that it works. Now we'll look at different kinds of solid, okay? They describe this solid because it doesn't have a name, okay? Like a sphere, right? A name. So this one, they need to describe the solid using using sentences here, right? So we'll need to read the paragraph here and try to draw it out, okay, based on what it's saying. So here we have the base of a solid, right? Base means the bottom. So think about a tissue box, right? So if you lift it up and look underneath, right, the shape that you see is the base of the solid, okay? So you need to understand what it means. The base of solid is the part that's touching the ground. Okay, so here it says this solid has a base in the first quadrant, okay? And bounded by x-axis, y-axis, and a straight line, right? X plus 2y equal 8, okay? And then the cross section of the solid is perpendicular to x-axis, and they look like semicircles. Okay, that's the hardest part to understand, right? think about the sphere, okay? The cross section that I make is also perpendicular to x-axis, right? Think about the way I cut it. I have to cut it vertically to make the red circle, right? So this way we say the cross section is perpendicular to x-axis. If it's perpendicular to y-axis, then the cross section will look like this, the green one. Okay? The green one there on the sphere, that's perpendicular to y-axis. Okay, so that's the meaning of it. Okay, let me erase the green one. Okay. Now let's draw the picture out. Okay, so first of all, right, first part is saying you have a base in the first quadrant. So we need to draw the axis, right? So what we are trying to draw first is the base, okay? First part is to draw the base. So base of the solid is in the first quadrant, bounded by x-axis. So this is the x-axis here, right? X-axis. And the y-axis, right? Y-axis. And the line, x plus 2y equals 8. Okay, so we need to know how to draw this line. So let's isolate the y. All right, so can you please isolate the y and raise your hand? Because we only have first quadrant, okay? I'm gonna make the picture just focus on first quadrant, okay? So you have bigger space. All right, so what's the equation then? Carrie, y equals?
I think -1/2 x plus 4.
Okay, -1/2 x plus 4, very good. So that means we have a y-intercept of 4, right? So let's draw that out. 1, 2, 3, 4. Okay, and then if I want to find x-intercept, okay, x-intercept, I need to put y as 0. Okay, so what is the x-intercept? Okay, so can you raise your hand if you found the x-intercept? Okay, put y as 0 and find the x. So Leon, what do you have for x-intercept?
8.
8. Yep, very good. Okay, so let's draw that as well. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we have a line. Okay, so this line is x plus 2y equal to 8, right? Or y equals to -1/2 x plus 4. And then we have another boundary, right? The y-axis and the x-axis. So the shape of the base is a triangle. Okay, so they don't tell you it's a triangle. They ask you to draw it out and then you see it. Okay, it's a triangle. So this one, you can think of it as a bird's eye view, right? Because you're looking from the top, looking down at the solid, okay? And the shape of the base is the triangle shape, okay? So top view, okay? We'll just say top view or bottom view, okay? Bottom view. Okay, looking from the bottom, so you see a triangle. Now we need to draw the cross section now, okay? So it says we want to cut it perpendicular to x-axis. So that means the cutting is this way, right? Perpendicular to x-axis. So for every cut, it creates a cross section that's semicircle, okay? So for example, I cut it down it makes a solid, but that solid is going to stand, it's going, the solid is standing out of the page, okay, towards you, okay? So maybe I should say this as the top view, will make more sense, okay? Looking from the top, okay? So it makes a semicircle, like that. Okay, for every cut, let's say if I cut here, it makes another semicircle. The semicircle, each of the semicircle is coming out of paper, okay? It's standing upwards. Okay, it's not flat. So you have a lot of semicircle, okay? I only drew a few, right? But in fact, they are infinite. Okay, the further to the right, okay, the further to the right, the semicircle, it gets smaller, right? Because it's constricted by the boundaries.
Jason?
Questions? Yeah?
Wait, so when I like take a slice of it, the slice comes out as a semicircle?
Yes.
Oh, okay.
Okay, now let me draw another picture which is looking at an angle, so it looks more 3D, okay? So this is looking from the top. So you are not supposed to see the semicircle when you look from the top. Just like when you are looking down at your water bottle, right? Then you won't be able to see the height of it if you are looking directly down. Or you think about you are looking from the airplane, right? And look down on the houses. All you see is just the roof, little rectangles, right? You won't be able to see the side of it, right? Because the roof, if you look 3D, it will have this shape. But if you look from the top, it's just a rectangle, okay? Yeah, a lot of imagination here, right? So now I'm going to draw the 3D, okay? So that you can see at an angle. So I'm going to place x-axis this way, y-axis slanted because it's lying flat on the ground. And then there is a z-axis, okay, which represent the height, okay? And then the green boundary line, this is 1, 2, 3, 4 for the y, and then 8, let's say, is here. So the line goes this way. Okay, and for the cutting, okay, if I cut here, if I cut, the biggest one will be here, makes a semicircle. If I cut here, it makes another one, So kind of like a cone, right? But it's half of the cone. Okay, it's standing out of the page. Okay, it's 3-dimensional. Okay, do you get a picture? Can you show me hands if you understand the picture? Yeah, okay. So do you guys need time to copy down the picture? Okay, let me know, raise your hand if you finish drawing, okay? And then we'll start setting up.
Wait, Jason.
Yep.
So basically the second picture you're just showing us from like an angle, right? So we can
Yeah.
kind of see the 3D view.
Yeah. Otherwise,
Okay.
the top view, you are not supposed to see any semicircle.
Wait, so for like when we do like questions like this, do we generally draw it from like top view?
Yeah, I will draw the top view.
Okay.
Draw the top view and then sort of cheating and then draw the semicircle at the same time, right? Because in fact, right, in reality, you cannot see the semicircle from the top view. But 3D is difficult to draw, right? So just
Yeah.
draw the semicircle on the top view. Okay, if you finish drawing, you can raise your hand so I know I can move on.
Oh shoot, sorry, I forgot to raise my hand.
Oh, okay. I'm waiting for you. Okay. Now volume, okay? So same concept, right? We need to add up all the area, okay? Sorry, the volume of the cross section, right? So for this case, we're adding from left to right. So what do you think the boundaries are? Where to where?
Is it from 0 to 8?
Yes, okay. So going from left, right? Left side, left end is the 0, right? And then the last piece is at 8. So 0 to 8, right? And then the area is talking about the area of the semicircle. And because it's changing depending on x value, so it will be a of x, okay?
Wait,
If
sir?
we, yeah,
Sorry. I was wondering, do we put out 1/2 to on the outside because it's semicircle? Or
later when we try to find the area, there will be 1/2.
oh, okay.
Right now it's just in general, right?
Okay.
Doesn't matter what kind of shape, it's always area of x times the thickness. The thickness is, for example, I take the middle piece, right? So thickness will be this one, right? Right, every single one has a little thickness, right? So this part is the dx, okay? Looks like a little lemon, right? A slice of lemon. Okay, so to find the area of semicircle, so that's where the Jesse said before, right? Area of a semicircle is what? What's the formula?
Half pi r squared.
Half pi r squared. The r here is the radius of the circle, okay? And then dx, 0 to 8. Okay, so the radius, because we need to write everything in terms of x, okay? So let me erase that dx now. Or I can use the top view, okay? So let's say I pick the middle one, right? So here's the x, right? Same question, right? Just like the sphere. Before I ask you, if I know the x, how can I get the radius? And then you told me you have to use Pythagoras, right? For that one, okay? This one, same thing, 5, right? That's over here. Okay, let me erase the other one. Oops. Okay, the one with the arrows. Okay, so that slice, if I know the x, how do I get the radius of that semicircle? Okay, think about this. You could pretend it's a number, right? So if x equal to 3, how do I find the radius of that lemon? Okay.
Jason,
Yeah, Jeffy.
all the triangles have the same angle, right? Because they all end at 8.
Yeah.
So if you know x equals 3, then
Yes.
you know the distance between 3 and 8 is 5.
Between 3 and 8 is 5. Yeah.
Because I'm thinking you can do ratios, right? Because then
Uh-huh.
8 and 4 would be the same ratio as 3 and whatever the radius is. Or sorry, 5 and whatever the radius is. So
Okay. You mean
so
this?
the base yeah.
Yeah. Is that the radius?
So the very
Huh? Would you
yes.
call that a radius? The blue line.
Oh wait, no, that's the diameter.
Mm-hmm.
But then half of that would be the radius.
Yeah, that will work. Very good. So how do I set it up? Can you help us?
Okay, because I didn't really think this entirely out, but it just came to my mind.
Very good. Let me put the letter first, okay? D for diameter here. Okay, so how do we get the D?
Okay, I would write it as 4/8 first.
4
that's
to 8.
Like, yeah, and then that equals to big D over 5.
5. Okay, yeah, D to 5. Okay, and once you get the D, you can cut in half, right? You get the radius.
Yeah, and then that would be the radius.
Okay, now we want to make it more general. Okay, so let's say I erase this. If it's just X,
Mm-hmm.
then how do I set it up then?
Would it be? I guess would it be dx because it's a change in x?
Dx is for the thickness, the small thickness though.
Oh, okay.
Hey, Jason.
Hold on. Not yet.
Okay.
Right, remember you have to get the 5, right? How did you get the 5?
It'd be 8 minus x.
Yes, okay, so it will be the general, right? So how do we set up the ratio?
So I guess 4/8 equals d over 8 minus x.
Equal d over 8 minus x. Yeah, okay, and then from there we can isolate d, right? Isolate d and then cut in half again. Make sense? Any question? Anyone has question about this? That's one way to go.
Yeah.
There are other ways. Jesse, what do you want to say?
I'm a little confused because I thought like last question we said the radius equals to root r squared minus x squared.
Mm-hmm.
I don't know if that's only for that question or if that's in general, because I remember you said something like you changed all like the variables to be in general. Because like we can apply like the same logic, right? Because it's still like circle.
Okay, but then before was a sphere, so that's why the sphere, the radius is always the same. The radius of the red, right, is restricted by the radius of the sphere. Okay, the restriction is different. Okay, it's inside the sphere, but for this one, it also has radius for the cross section, but then this time the radius is restricted by the triangle, right? It follows the shape of the triangle instead of the shape of a sphere. Make sense? Jesse?
Yeah, thanks.
Yeah, okay. So you got to work on the spot, right? Depending on what the shape look like, and then try to get the radius. Okay, so let's complete the Jeffy's way first, okay? I'm gonna grab this part. Okay, take this, fold it up, Okay, so let's isolate the D, okay, the diameter. So D will be, the left side will be half, right? So it'll be half 8 minus x, right? Cross multiply. Okay, so that means the radius of the each lemon, right? Radius of the lemon, it will be half of the diameter, right? So it will be 1/4, 8 minus x. Any questions? Okay, anyone got lost? So we can simplify this more, right? Expand the bracket so you get 2 minus 1/4x. Okay, so this is going to be the radius. So this is one of the way, right? Very good. No one before has told me this way, okay? So using similar triangle. Now let's look at this differently, okay? If I want to find radius, we need to get the diameter, right? We need to know a diameter, and the diameter, the length of the diameter depends on how tall the green line is, right? For example, if I shift the x, okay, let me erase this x. If I make the x go to the left, then your diameter will be longer, right? So it's depending on the green line, right? That's cutting through from 4 to 8, right? Every diameter depends on the green line. So the green, how tall the diameter is actually the y value of each x, right? So if I know the coordinate, okay, if I know the coordinate of the point, then I would know the diameter, right? So basically the y is the diameter. So diameter is the y of the equation of the line. Make sense? So let's take a look, right? The y we got before was this one, right? Y equals to half x plus 4, right? So diameter is half x plus 4. So if I cut that diameter in half, then that will also give you negative 1/4x plus 2, right? So you see, it's the same. Okay, we have radius using Jeffy's way, or radius using the equation of the line. Okay, so that way you don't need to set up ratio if that idea didn't come to your mind. Any question? Can you raise your hand if you get this? Okay, 2 different ways to figure out the radius.
Wait, sir?
Yeah, Jesse?
I'm still a little bit confused about the way Jeffy did it. Like, I understand the ratio part because those two are like constant, right?
Similar triangles.
Oh, okay, thank you.
Oh, you get it now?
Yeah, I just need to know how we got there. And similar triangles, yeah, I know.
Yeah, so like this, okay? So we have this part is x minus 8. So not x minus 8, 8 minus x, right? And then you have the diameter, and then you have the 4.
Okay, yeah.
And then this part is the 8. So that's Jeffy's similar triangle idea, okay? Still work. But the faster way will just be using the equation, because the equation just tells you how tall each diameter can reach, right?
Yeah.
Okay, so now we found the radius. All we need to do is plug into the formula, right? So 0 to 8, half pi r, right? R is this. Negative 1/4 x plus 2 squared, right? Pi r squared dx. So after that is a bunch of FTC, right? Fundamental theorem. take the constant out. You could use substitution if you want, or you could expand the brackets, right? And then do it one by one, okay? So after that, you can get the volume. Okay, we're not going into detail, okay? I think the hardest part is try to know how to get the radius and how to plug into the formula, okay? So question can change, okay? This area, A of X, okay, let me highlight it. The A of X here, the yellow highlighted. So far, the first example was circle, right? Sphere. This example is semicircle, right? But I could also change. They could say, okay, the cross section is not semicircle, it's a square. Okay, cross section is a square. Why don't we do that? Okay, how would you set up? Okay, so if cross section is a square, what will be the formula now? Okay, so please write it out by yourself. Okay, and raise your hand if you got the setup. Okay, you don't need to find the answer, just show me the setup. Not semicircle anymore. Every cross section is a square. So the 3D, okay, I'll draw a little picture quickly. Right, so square will be standing up. Right, that's one of the square. And then you could have another one. The more to the further to the right, the smaller it is, right? Square, right? And then another square.
Wait, Jason.
Yeah.
I think I have it, but I don't know if I did it right.
Okay, now let's wait for other people too. Okay, so the picture will look like that, looking at an angle, right? The 3D. So a lot of square piling up, okay? Infinite number of squares. So raise your hand if you got this set up. Does anyone have questions about the semicircle one? Okay, it's a square, right? So think about what's the formula for finding square. Okay, Carrie, what do you think? How far are you?
I'm still working on it.
Okay. You don't need to solve, okay? You don't need to get the final answer. I just need to know the setup, okay? Okay, Leon, what do you have?
Well, I'm not quite sure, but since it's a square, I'm assuming the x would equal the y, so wouldn't it just be x squared dx?
X squared dx. Okay, the x is only the location where you cut it. Right? When x equal to 1, that means you cut the cross section at 1. Okay?
All right, never mind.
How about Joan? Joan?
Hi, yes.
Yeah, do you have anything?
I don't know if it's right, but I put y cubed. I mean y. Wait. Y. Wait. You know what? I realized I did this wrong. Give me 1 second. Or I think it'd be y squared dx, wouldn't it?
Y squared dx.
Because it's like a square, so it's like the 2 sides.
Oh, okay. And what's the y?
Just the y-axis, the value on the y-axis. I'm not sure if I did this right at all.
I'm not sure if you are on the right track because it sounds right, but I need more details. So you got to elaborate more.
Oh wait, is it negative half x plus 4 and the whole thing is squared?
Yes. Okay. Yeah.
Wait, sir?
Yes.
I got 8 minus x squared, except now I'm kind of confused.
Okay. Let the ambulance pass first.
Oh, sounds. Why are there so many ambulances by your area?
Yeah, I live by the street.
Oh, okay, okay.
Okay, so this one, okay, okay, let's look at this picture, right? Even though here I drew a rectangle, okay, pretend they are square now, right? So area of square, what's the formula for area of square? Any square? Anybody? Area of square.
Like I guess x squared or whatever the same thing is squared.
Yeah, so the side times itself, right? Any side, make sense? Yeah, okay. So I'm going to use the purple, okay? Purple color. So let's say this side, right? If I know the length of this side, then I just square that. Then that's the area of the square, right? The more to the right, the further to the right, the shorter the base, right? The line, the purple line, right? It gets shorter as we move to the right side. So each of the line here, the purple line, the length of the purple line depends on the green line as well, right? So just like the diameter, what you saw there, right? The y value in the semicircle represent the diameter. The y value of the green line represent diameter, right? Because we have a semicircle. But if it's a square, then the y value represent the base of the square, the side square. Okay, right? For example, I can draw the square here, right? Using the same base, right? Another square, right? Another square, another square. Okay, so
Wait,
every
Jason.
single square
Okay.
depends on the y value. Yeah, Jesse?
Okay, never mind. You answered it. Thank you.
Yep, okay. So that's why if it changes to a square shape for the cross section, you just take the y, right? And then square that because the y is one of the side, okay? And
That's
after
where I got my answer. Sorry about that.
Joe, can you say
I
that
thought-
again, say?
I think that's where I got my answer. Because I thought you meant like just in general. That's why I said y squared.
Oh, okay.
Yeah.
Yeah, so that's why I said you could be right, but I'm not sure. I need you to.
Yeah. I just thought it meant in general, but yeah, in this context, then that makes sense.
Right. Okay. Very good. Right. So they can change the question, change the square. Then you do it like this. They could say, okay, this is a equilateral triangle. Then you have to do it differently, right? So depending on the question. All right. I think we will take a break, and then after the break, we'll do this method. Okay. So 15 minutes. Right. I'll see you at 45.
Thank you.
Okay.
Thanks, Jason.
Thank you.
You're welcome. Bye bye.